Good morning, all of you. The last 2 to 3 sessions, we have studied what is problem solving, how to define problem statements, what are the different problem solving strategies. Now, what we'll be seeing is we'll be seeing the exact way of solving problems. What really is the process involved in solving problems. We'll be seeing some real-time examples also along with this. Okay, so we'll be studying some practicals. Along with this, we'll be studying some problem statements. We'll be studying how to define and what are the problem statements that we are going to define, how to define it, and how to approach these problems using computational models. Why do we need computers? Okay, what is the need for computers in problem solving? So the topic given to you in the syllabus is computer as a model of computation. So when we want to use computers as a device that is going to solve our problems, we consider 3 types of problems. One, it could be a computational problem, logical or repetitive. A computational problem means you have a problem which requires high precision, high accuracy. Say for example, all of you know the value of pi, right? 22 by 7. Yes? 3.14 is fine. Yes? But if you want it up to 5 decimal places, what you will do? Can you remember it? No. In your physics, you would have studied the charge of an electron, right? What is the value? 1.6 into 10 raised to, that's only up to 1 decimal places. I want it to be more precise. Complex computations, it is always difficult for human beings to make it out very fast. So we depend upon computers to solve such kind of problems. The second type, logical. It involves logical processing where we need to do certain things by making certain logical decisions. Okay. As we go on, we'll be studying about logical circuits, we'll be studying about so many other kinds of real-time requirements for computing. But for the time being, you need to understand that we need to use computer as a model for problem solving in most cases, in these 3 domains. First one for computational, second one for logical, and third one for a process that is going to be repeated n number of times. If a same process has to be repeated n number of times, you may need to use computers because it is not feasible or it is not as efficient or it is not accurate to determine all these processes or all these steps manually. If you wanted to do all these things in a very quick manner, in such a way that all the information is readily available to you that can be used for solving your problems, we need to use computers. Okay, so we are learning to use computers as a model for solving our problems. These are the 3 kinds that generally exist while solving problems. Okay? So in general, we can classify the problems into 3 categories. First one is computational, second one is logical, and third one is a repetitive process. Okay, so all problems or majority of the problems that we come across can be categorized in either of these three categories. So the problem solving process as such, in the problem solving process, we have a few important points that you have to remember. The first thing that you need to do before you solve the problem is to understand the problem. You have different stages which we need to come across while using computer as a model to solve the problems. The first one is that you should have sufficient knowledge about the domain. Understanding the problem is the first step in problem solving process. The first step in problem solving process is understanding the problem. Understanding the problem consists of a few important steps or things that you need to do. First is that you should understand the domain in which the problem lies. Okay, there would be different kinds of problems, engineering, non-engineering, and so on. So you need to understand which is the domain in which the problem lies. Second thing is analyze the inputs. What are the inputs that you need to give to the system so that it is going to do some process and display the outputs? Right? So, first point is that the knowledge of the domain, and then you need to define the inputs. Then you need to define the inputs. Then you need to understand the process, and then you need to have the output. So this particular thing, the first stage in problem solving process is understanding the problem. In the next slide, I'll explain to you this particular step with an interesting example. Or the example which we have already discussed also can be considered. Okay. So let me start the example. Now, as I told you, I wanted to find out the largest number in the list of numbers given below. Consider this to be a problem. Or I wanted to find out, let this be the marks of a few students, say 8 or 9 students. I wanted to find out the student who has scored the highest mark. What is the highest mark here? Which is the highest mark here? 71. You could easily find it out, it is 71. Do you know that how your brain had come to a conclusion that it is 71? Let me ask you another question. 1, 2, 3, 4, 5, 6, 7, 8, and 9. There are only 9 values given to you and you are asked to find the highest number. What if 30 numbers are given to you and you are asked to find the highest number? How long will it take? What if 300 values are given to you and you are asked to find the highest numbers, highest scorer? I have 9 students. I can easily tell you which is the highest mark among these 9 students. But what happens if I have 30 students, 300 students, 3,000 students, or 3 lakh students? Don't you think that the time taken or the process would become more complex? Don't you think that it becomes almost impossible for you to manually calculate or manually find out the largest number? In that case, how do you think you can approach this problem? Now, don't you understand that understanding the problem requires intelligence, because you need to explore different domains, different areas, different ways in which your solution or your problem can be solved. Okay, the next step 2 in the problem solving process is to formulate a model for the solution. So we have a brainstorming process here. Brainstorming process is the way you are thinking about the problem so that you can have a solution to this problem. Okay, so you need to formulate a method through which you can find out the largest number in a given list of numbers. You are given a list of numbers and you are asked to find the largest number. When you look into this, you can logically find out which is the largest number. But what is the method that your brain, or what is the model that your brain works with, which you are able to find out this is the highest? That is my question now. So here, these are the list of numbers: 10, 8, 9, 17, 64, 12, 32, 71, and 23. How you are going to find out the largest number? You will check. Let me take 10 to be the first number. Okay, I'm going to devise an sample model. It need not be the same way. You can have different ways of doing it. One way of doing it is that you can take the first number, compare it with the second number. Okay, you can take 10, check with the second number 8. If the second number is greater than the first number, you can replace the largest number to be the second number. If the second number is bigger than the first number, let us consider L. Say, let me take you for example. Let me consider L to be the, one second. Let me consider L to be the largest number here. Okay, please listen to me carefully. The end of the slides, I'm giving you assignments which you need to do it yourself. Let me consider the largest number to be 10. Okay, I am comparing the largest number with the second number, that is 8. If 8 is smaller than 10, I'm going to do no change. I'm going to compare this largest number again with the second number 9. Here again, 9 is smaller than 10, so there is no change. Right? Then what I'm going to do, I'm going to compare the largest number 10 with 17. So when I come to 17, what happens is that when I come to 17, 17 is larger than 10. So what I am going to do, I am going to replace this with 17 and compare 17 with 64. Okay. Again, since 64 is larger, I will again replace the 17 by 64. Understood, all of you? This is a methodology, or this is the way in which you are formulating a model wherein you can find the largest number in a given list of numbers. Okay, this is one simple method. You can have different kinds of method, different kinds of algorithms are being devised to find the largest, to search, and to sort, and so on. So this is what is meant by formulating a model. When I say I am going to formulate a model, I am going to systematically define a method through which I can solve the problem. My problem here in the example which I am teaching you is I wanted to find out the largest number in the list of numbers. When I look into that, I can simply do that, but I need to formulate a model because I need to. Here I am taken only 9 numbers as examples. As I told you, if I need more, if I need to compare 300 numbers, it might be difficult for our mind to capture all the 300 numbers and bring out the solution. Am I right? Yes or no? So when I devise this model, this can be applicable to 300 or 400, whatever it is, right? Or even 3 lakh numbers I can find out. Okay? So the model here, I have explained this in words. I've taken 10 to be the largest one. I've compared 10 with 8, 8 and 10 with 9 again, and 10 with 17. When it comes to 10 with 17, what happens? 17 is larger than 10. So I've replaced the largest number with 17. And then I'm comparing 17 with the next number, and so on. This is the logic, or this is one among the several logics that can be applied to find out the largest number from a given set of numbers. So you understand what is meant by formulating a model? All of you? So now we are going to write an algorithm to find out the largest number from a set of numbers. Here we have taken up 9 numbers, 9 random numbers for example. Like what we have done in the morning. So we have a box, the red box which stores the largest number. Let us assume that the largest number is 10. Okay, 10 is being written here. The next number is 8. So 10 is compared with 8. Since 8 is less than 10, nothing is being done. Next, 9. Next number here is 9. 10 is compared with 9. Okay. Again, 9 is less than 10, so there is no change. But what happens when the next number comes? 17. There is a change. 17 is larger than or larger than 10. Greater than 10. So what we do? We change the largest number to 17. And then what we do? The next process, we compare 17 with 64. Here what happens? 64 is larger than 70. So what it happens? Again there is an exchange. So the largest number again now becomes 64. Next, again 64 is compared with 12. There is no change because 12 is less than 64. Next, compared with 32. 32 is less than 64. So what happens? No change. Next comes 71. 71 is greater than. So what happens? There is a change. Next, what we'll do? We'll compare 71 with 23. There is no change. So we declare that 71 is the largest number. So this method or finding out a reasonable solution with which you can find out answers is called as formulating the model for a problem. Okay? Are you all able to understand clearly? Yes. The next step in problem solving process is to develop an algorithm. In the previous class, I have given you the definition for an algorithm. Algorithm is a step-by-step process of solving the problem so that you get the right solution. Okay. So here, for this example which I have been teaching you, I have written down an algorithm. Algorithm step 1, first step is to initialize the largest number to be the first number in the list. Right? And then for every element, for each element in the list, this will keep checking and then we'll keep updating the largest number. And finally, what we do, we return the, after checking all the numbers, the entire list should be checked like this. And after it has traversed through the entire list, what happens is that we get the largest number and the largest number is returned as the solution to that problem. So this is, so after you have written the algorithm, what we have to do is that we have to program this. We have to make this as a computer executable program. So that's the fourth step in problem solving process. So in the fourth step, we are going to program, we are going to write a program that is going to find the largest number or the student with the largest marks in the list of the marks that is given here. Okay, for that, I've created a group or a list. What we call a list is a collection of data. Okay, collection of information put together. It is within square brackets. I will teach you what is a Python list in detail when we come into that topic. But now, for the time being, you can understand that list is nothing but a group of data, collection of data. So in this collection, I've put a collection of data or collection of all the marks together in a single name, marks underscore list, and this is called as a variable. What is a variable also I will be explaining to you in detail in the next lab session. So now I'm going to define another one variable called as largest, which is going to be nothing but the first value in the list. So I'll tell you how to take out the first value in the list before I go with this. Okay, I'll just remove this. I'll just copy this, and the first value in the list marks underscore list of 0. This is called as index. When I put marks underscore list of 0, it means that it is going to capture the first value, that is the 10. Now, if I make it as 1, it is going to be 9. Sorry, 8, 2, 9, 3, 17. Okay, so mark list of 0 is going to bring out the first mark or the first value in this particular list. I am going to equate this to largest. Let the largest value be marks of 0, that is the first value. As per our algorithm, what we are going to do, we are initializing the largest number to be the first value in the list of all values. Next, what we are supposed to do is that we have to compare this with all the elements in the list. So we need to have a variable, we need to have a loop. In a loop, what we are going to do is that we are going to take this value. Say, for example, all the values in marks underscore list. Okay, to take all the values in marks underscore list, I have to go from this to this. If marks, so here, if marks is greater than largest, then the largest will get replaced with marks. And then I am printing the largest value. So when I run this program, what happens is that I get 71, that is the largest value in the list. There is nothing to worry if you have not understood how the coding is being done. We need to understand that the fourth stage in the problem solving process is writing the program to solve the problem. Okay. So the next step in problem solving process, the next step is to check the code, testing the program. We need to check and evaluate the correctness of the program. The final sixth step, the sixth step in the problem solving process is to evaluate the solution. Now what we mean by this is that now we know that what happens if there is a negative number, or what happens if something else happens, what happens if the numbers are too large. Okay, so all these things are required to evaluate a solution in such a way that your program works in very different kinds of environments. So we are evaluating the solution, we are finding out the answer, and from the answer we are checking out how far it works properly. So evaluating the solution means checking out its metrics, efficiency, feasibility, scalability, and so on. There could be so many other factors you can, it depends upon the projects. Next, to summarize, these are the steps. So, to summarize the basic points, in the problem solving process, we begin with the first step, understanding the problem. Second step, formulating a model. Third step, develop the algorithm. Fourth step, write the program or coding. And fifth step, test the program. Sixth step, evaluate the solution. This is the summary of what we have done today. Is that clear? So now we are going into the most interesting aspect of today's class. I'll be giving you some beautiful questions for you to solve, and you will start solving it. So these are the assignments I want you to solve. These questions you can even copy from YouTube if it is not possible right now. I don't want you to write it now. I think that this thing will be available in your all the means, wherever you want it to be available. So now we have devised an algorithm to find the largest in a list, marks. Whenever you are booking flight tickets, you know how many of you have regularly booking flight tickets? Online flight ticket book ചെയ്താരെങ്കിലുണ്ടോ? No. No, whenever you search for a air ticket, airfare, when you book flight tickets, say for example, when you search for flight tickets from Coimbatore to Delhi, Delhi for example, you will get the list of airlines in the decreasing order. The cheapest flight will be given in the top place. Have you noticed that? There would be so many other examples. Even when you are booking rooms in Oyo rooms or in search, even when you are searching in your Amazon or Flipkart or wherever, order according to prices, the lowest, the highest, and so on, right? Yes or no? So, arranging in ascending, descending orders. So, if you are searching for some material even in Amazon or Flipkart or wherever you like, you can see that the prices sort according to prices, sort according to size and so on, right? So sorting is a very important function, very commonly used in several places. We need it. It's very important. That's the reason why we need to learn all this process. So here you need to write an algorithm to find the smallest number from a list of random numbers. The second algorithm you have to write is slightly one step higher than the previous one. What you have to do is that you will be given a set of numbers, you need to arrange it in ascending order. The list of numbers should be arranged in ascending order. You should write an algorithm. For all these things, algorithm should be written, okay? All the first step, second step, third step, and so on. Okay? So you have to arrange it in ascending order from a list of random numbers. Third one, suppose a number is, find the frequency of a number. You might have done it in statistics and so on. You have a list. You have 10 repeating 2 times. So if the list contains 2 times and if the number is 10, you should tell that 10 repeats 2 times. You need to write the algorithm for that. So you have to understand, for every problem, you need to understand what are the inputs. For the first problem, input is nothing but a list of numbers. Simple list, and you are finding out the smallest number in the list. For the second problem, you have the same list of numbers as the input and you are just arranging it in ascending and descending order. But for the third problem, you need a list as well as another one number for which you have to count the number of times that number is appearing in the list. You understand? The third problem requires 2 inputs. The first problem and the second problem is only a list of numbers. The third problem, you need to have another number also, and you need to check whether how many times that number appears in the list. Are you able to understand? Is there any doubt in understanding these questions? No. And the last algorithm that you need to do is about, you have a basket which contains both red and green apples. You need to write an algorithm in such a way that you are picking up only the red apples. What are the steps you will do? The problem is very clear. You need to bring out the red apples from a mixture of both red and green apples. Can you all do this? Can you write the algorithms for this? So thank you all. Thank you very much.